All right, well, still darkness. The bird came really close to flying out the door, but he didn't figure it out. He has about 20 more minutes before I'm going to lock him in for the night. All right, so moving on. Well, let's get this right slideshow right here. Here we go. From current slide here, let's take away that. Here is our far side. Down, cows playing games. All right, moving on. 35.3, fighting infectious disease. The goal is to discuss the need for adequate monitoring of environmental parameters when making policy decisions. Our objectives are to distinguish between active immunity and passive immunity, describe how public health measures and medications fight disease, and describe why patterns of infectious disease have changed. Oof. So think about it. More than 200 years ago, English physician Edward Jenner noted that milkmaids who contracted a mild disease called cowpox didn't ever develop smallpox, which is what it looked like, but it would cover your whole body. At the time, smallpox was a widespread disease that killed many people. Could people be protected from smallpox by deliberately infecting them with cowpox? That was the question that Edward Jenner asked himself. And how he conducted his experiment was highly unethical, but he developed vaccines because of it. So our first objective is to distinguish between active immunity and passive immunity. So back to Dr. Edward Jenner. He performed an experiment in which he put a fluid from a cowpox patient's sore into a small cut that he made on the arm of a boy named James Phipps. What parent would allow that? I don't know, but they did. And as expected, James developed a mild cowpox. 2 months later, Jenner injected James with fluid from a smallpox infection. The boy didn't develop smallpox. Oh my God, I can't believe his parents let this happen. The boy's cowpox infection had protected him from smallpox infection. The injection of a weakened form of pathogens, or of a similar but less dangerous pathogen, to produce immunity is known as a vaccination. Today, the word vaccination comes from the Latin word vacca, meaning cow, as a reminder of Jenner's work. Interesting, though. That's where vaccination comes from. Vacca means cow. So, active immunity first. Active immunity may develop as a result of natural exposure to an antigen, fighting an infection, or from deliberate exposure to an antigen, like through a vaccine. Vaccination stimulates the immune system with an antigen. The immune system produces memory B cells and memory T cells that quicken and strengthen the body's responses to repeated infection. Antibodies produced against the pathogens by other individuals or animals can also be used to produce temporary immunity. If externally produced antibodies are introduced into a person's blood, the result is passive immunity. Passive immunity lasts only a short time because the immune system eventually destroys the foreign antibodies. Passive immunity can occur naturally or by deliberate exposure. Natural passive immunity occurs when antibodies are passed from a pregnant woman to her fetus, like across the placenta, or to an adult infant, through breast milk. Some diseases, antibodies from humans or animals can be injected into an individual. For example, people who have been bitten by rabid animals are injected with antibodies for rabies virus. So our first objective was to distinguish between active and passive immunity. Active immunity is like a vaccine stimulates the immune system with an antigen. The immune system produces the memory B and memory T cells that quicken and strengthen the body's response to repeated infection. Passive immunity, on the other hand, are antibodies produced against the pathogens by other individuals or animals that are used to produce temporary immunity. So objective 2 is describe how public health measures and medications fight diseases. So in 1900, more than 30% of the deaths in the United States were caused by infectious disease. In 2005, less than 5% of deaths were caused by infectious disease. Nice big jump there, right? Two factors that contribute to this change are public health measures and the development of medications. In 1854, Dr. John Snow learned, through interviewing residents and mapping, that the source of the London cholera outbreak was from a water pump, right here. This is a major event in the history of public health. So the field of public health offers services and advice that help provide healthy conditions. So he narrowed it down to this one location, this water pump, and then, of course, government, the city, took action to help deter that, to clean that water pump. Promoting childhood vaccinations and providing clean drinking water are two important public health measures that have greatly reduced the spread of infectious diseases. Medications, such as antibiotics and antiviral drugs, are other weapons that can fight pathogens. Antibiotic is a compound that kills bacteria without harming its host. In 1928, Alexander Fleming, as you see here, noticed that a mold, penicillin, seemed to produce something that inhibited bacterial growth. Research determined that this something was a compound Fleming called penicillin. Researchers learned to mass-produce penicillin just in time for it to save thousands of World War II soldiers. Antibiotics have no effect on viruses. However, antiviral drugs have been developed to fight certain viral infections. These drugs generally inhibit the ability of viruses to invade cells or to multiply once inside cells. So our objective 2 is describe how public health measures and medications fight disease. Public health measures help prevent diseases by monitoring and regulating food and water supplies, promoting vaccination, and promoting ways to avoid infection. Antibiotics can kill bacteria, and some antiviral medications can actually slow down antiviral activity. Objective 3 is describe why patterns of infectious diseases have changed. By 1980, many people thought that medicine had conquered infectious diseases. Vaccination and other public health measures had wiped out polio in the United States and had eliminated smallpox globally. Antibiotics seemed to have bacterial diseases under control. Some exotic diseases remain in the tropics, but researchers were confident that epidemics would soon be history. But in recent decades, a host of new diseases have appeared, including AIDS, SARS, hantavirus, monkeypox, West Nile virus, Ebola, and avian flu, bird flu. Other diseases that people thought were under control are re-emerging as a threat, spreading to new areas. Pathogens are evolving in ways that enable them to infect different hosts. As people clear new areas of land and as environments change, people come in contact with different pathogens. Exotic animal trade for pets and food have also given pathogens new opportunities to jump from animals to humans. In 2003, dormouse from Ghana spread monkeypox to prairie dogs in the United States, which then infected humans. The spread of SARS has been associated with the wild animal trade. Misuse of medications has led to the reemergence of diseases that many people thought were under control. For example, many strains of the pathogens that cause tuberculosis and malaria are evolving resistance to the wide variety of antibiotics and other medications. In addition, diseases such as measles are making a comeback because some people fail to follow vaccination recommendations. So objective 3 was to describe why patterns of infectious diseases have changed. Two major reasons for the emergence of new diseases are the ongoing emerging of human and animal habitats and the increase in the exotic animal trade. Misuse of medications has led to the reemergence of diseases that many people thought were actually under control. So all of our objectives again to distinguish between an active and passive community, describe how public health measures and medications fight disease, describe why patterns of infectious diseases have changed, all support the goal that discuss the need for adequate monitoring of environmental parameters when making policy decisions. And there is a cute-ish kind of picture. All right, guys. Thank you.